Let's solve Leetcode 581. This problem is also part of the 3rd May 2022 Leetcode challenge. In this problem, we are given an array nums and we need to find one continuous subarray such that if we sort that particular subarray in ascending order, then the whole array will be sorted in ascending order. So we need to return the length of the subarray. For example, let's take the example that is given in the question: 2, 6, 4, 8, 10, 9 and 15. If we sort this particular subarray in ascending order, then the whole array turns out to be ascending. So if this particular subarray is sorted, then the whole array becomes sorted. And so the output which you have to give is the length of this particular subarray, which is 5. Similarly, if we take a sorted array 1, 2, 3 and 4, then the output of this will be 0 because we don't have to sort any array. And let's take another example. Let's say 1, 4, 5, 8, 9 and then 7. In this case the answer will be 3 because we will need to sort this array and the size of this array is 3. After sorting this, it will become 7, 8 and 9 and we have 1, 4, 5, so the whole array becomes sorted. So let's thinking of a brute force solution. So let's think of a brute force solution. So let's find out the let's keep a sorted array, that is the array we want. So on sorting the given example 2, 6, 4, 8, 10, 9 and 15, we get this particular array, and then we only have to find the boundaries for which they are mismatching, and the length of the boundary will be the answer. So in this case 2 and 2 are matching, so it will not be the leftmost boundary. But as we come to 6 and 4 are not matching, so this has to be the boundary of the array. So let's call this L, or let's call this beginning. And similarly, when we move on from the right side, 15 and 15 are matching, but 9 and 10 are not matching, so this has to be the rightmost boundary. Let's call it end. So the difference between end and beginning will be the output, that is end minus beginning plus 1 gives us the size of the subarray which needs to be sorted. Now this algorithm will take order of n extra space for storing the new array, and it will take n log n for sorting the array, plus it will take a n for traversing the array to find the boundaries, plus another n to find the rightmost boundary. So finally it turns out to be an order of n log n in time. So the space complexity of such a solution will be order of n and the time complexity will be n log n. Now let's try to find a better solution. In fact, we can solve this problem with order of n time and in constant space. Let's look at how we can do that. So with the example that we solved, let's consider an array. Then we know that some part of the array will already be sorted. Then there will be some part which needs to be sorted, and this length is the answer. And there will be like some part from the end which again will be sorted, and the length of these sorted parts can also be 0. Now if we look at this unsorted part, let's consider this element, the firstmost element of the unsorted array, to be the minimum element. Let's call it mi, and let's call the maximum element of the unsorted array to be ma. So if we can figure out the places for mi and ma in the array, then we can find out the length of the array. For example, if mi's correct place should be beginning and ma's correct place should be end, then we can say that the answer will be n minus beginning plus 1, right? So how do we find out this mi and ma, right? So given an array, we can first find till which part the array is increasing. Let's say that the array is increasing till this part, and after this part the array sometimes decreases, sometimes increases. So we know that this part is sorted, so mi will be occurring in this part. Now mi is a minimum element, so we can take the minimum element from this part. Let's call it mi. So we'll take the minimum from all these elements and we'll call it mi. And then from the original array, we'll find the correct place for mi. So let us take an example which will help us understand this better. Let's consider 2, 4, 8, 9, 3, and then let's say 7, and then 10 and 11. Let's consider this array. For this array, for this is the increasing part. After this, the elements starts to fall. So we can find the minimum mi in this. So this turns out to be 3, right? And then we have to find the correct place for 3. So the correct place for 3 will actually be this, the first index. Considering 0 indexing, the first index will actually be the correct part. So we can say that beginning should occur here, right? And now similarly we can find the end by finding out the maximum element. How do we find out the maximum element? So let me just write it down again. 2, 4, 8, 9, 3, 7, 10, 11, right? So we traverse from the end and we find out the uh, sorted suffix till where it is perfectly sorted. So we find that 7, 10 and 11 are sorted. After this, the array is not sorted and the maximum element should be present somewhere here. So we find out the maximum between all these elements and we find it to be 9. And then we have to find the correct place for 9. So the correct place for 9 should be this element, that is in place of 7, and 7 is at the index 0, 1, 2, 3, 4 and 5. So it should be at the 5th index. So we find that end is the 5th index and beginning is the 1st index. So the length of the array that has to be, so the answer should be 5 minus 1 plus 1, which is 5. So the array that has to be sorted is from here till here. Once we sort this particular array, the whole this particular sub array, the whole array turns out to be sorted. So let me just write the pseudo code of which we discussed till now, of what we discussed till now. So first of all, we find out the minimum element after sorted prefix. Then we find the correct place for that minimum element. And similarly, we find the maximum element after sorted suffix. And then we find out the correct place for ma. The correct place for mi is the beginning and the correct place for ma is the end, and then the answer will be end minus beginning plus 1, right? And all these steps will take order of n. All these 4 steps will take order of n because there will be a linear traversal, and so the final time complexity will be order of n time, and we'll be using constant space. So we'll be taking no new arrays or stuff like that. So it will be constant space. So yeah, so the space complexity will be constant. Now let's take a look at how we are going to code this. So initially we'll declare all the required variables. So we'll be taking an integer I, and to find the indexes, let's take a beginning and an end, and I'll initialize this to -1. Let's take an integer n to store the size of the array. So first of all, we need to find out the sorted suffix, till which part is the array sorted. Sorry for the prefix. So we find the sorted prefix. So we travel from the first element to the last element, and if the number at index I is less than the number at I minus 1, it means that the sorted prefix is over and it has started to go down. So we'll break out from here. That is till index I minus 1 it was sorted, and from index I the sorted prefix starts to break. So the sorted prefix was just till I minus 1, and then we find the minimum element from index I till end. So it will be from index I till the end of the array. And now we have to find the correct place for mi. How do we do that? So we traverse the array, and if the number at index I is greater than mi, that means the correct place for mi should be at I. So we'll call beginning as I, and we will break out from the loop. Now we have to do this similarly for the end part. So for end, we have to find out the maximum element after the sorted suffix. So we'll find out till which part is the array is the sorted suffix occurring. So for n minus 2, I is greater than 1 and I minus minus, I is greater than 0 and I minus minus. If the number occurring at ith index is greater than the number occurring at the I plus 1th index, that means the sorted suffix is over. So we'll break out. So the sorted suffix was till I plus 1, and now we have to find the maximum element from the starting till the ith index. So it will be from the starting till the ith index. So we have found the maximum element. Now we have to find the correct place for the maximum element. So the correct place for the maximum element we'll find out as follows. So we'll traverse the array from the end, and if nums of I is less than ma, that means the ith index should be the correct place for ma. So we'll set end as I and we'll break out from the loop, and then the answer will be n minus beginning plus 1. Now we haven't taken the case into consideration where the array is already sorted. So if the array is already sorted, then after we break out from here, or after this first for loop ends, then I will be n. So we can check that to take care of that case. If I is double equal to n, we can return 0 as the array was already sorted. So let me just comment it out. Find the correct place for mi using this code, and we find the correct place for mi. And let me also say what mi means. Mi is the smallest element in the range which we have to sort so that the whole array becomes sorted. Instead of range, let me call it subarray. And similarly, I'll just paste it for MA, and instead of smallest, MA is the largest element. Now let's run the code. Okay, we are getting an error. Okay, this is nums beginning plus I, my bad. So anti-MA is equal to max element from the starting till the ith index. Okay, so this particular index takes the uh, indexing from 0, so the end index is not actually inclusive, so I have to write I plus 1 if I want to include till I. So that's why I wrote I plus 1. You can actually check the syntax and the inputs for max element in the STL. So this is basically something like this. This function is something like this: from A and B, but B is not inclusive, right? So this is how the max element function works. So that's why I wrote I plus 1. I had initially written I, that's why it was given a wrong answer. Now it's giving, let's run all the test cases. It's working, and let's submit the code. Yeah, as you can see, it's working perfectly fine. If you found this video helpful, sub will be very much appreciated. And if you like this video, please consider giving a like. Thank you so much for watching.